In this example, we are going to use our calculators to determine the solutions for these problems, but we're also going to use a unit circle to confirm the results, and vice versa. It's easy to simply rely on a calculator for the computation, but the calculator alone does not give us an understanding of what is occurring. Applying the unit circle will give us some relevance to what's being asked. So for this first problem here, A, it says 3 times the sine of 150 degrees. So on my calculator, I'm just going to type in the sine of 150 degrees. Again, I use the TI-30 calculator. My sine key is right here. So I'm going to type in the sine of 150 degrees. Always close off that parenthesis. So the sine of 150 degrees, that's 1/2. So 3 times 1/2. And if I just go ahead and do times, I get this answer up here, ANS. That means the last answer times, and then I'm going to say 3. And of course, that comes out to be 3/2. So the sine of 150 degrees is 3/2. Now, of course, I'm going to use my unit circle to check my results, to confirm my results. So if I go ahead and I put in 150 degrees, that's probably right around here. All right, if this is 90 degrees here, this is 60 degrees here, that gives us 150 degrees. And if this is 60 degrees here, then this right here is 30 degrees. And of course, what results is a 30, 60, 90 special right triangle, which we've been using to find these lengths. And this is the length we want to find. The sine, that's the opposite over the hypotenuse. And of course, this length right here, that's a vertical length. Using the pattern for our 30, 60, 90 special right triangle, this is going to be 1/2. And of course, 1/2 times 3 gives us 3/2. But the key is that it's the opposite. Sine is the opposite over the hypotenuse. And since this opposite is a vertical length, sine is relative to the y-coordinate. The y-coordinate gives us our vertical measure. If this was cosine rather than sine, if this said the cosine of 150 degrees, the cosine is the adjacent over the hypotenuse, and the adjacent would be this horizontal length here. That horizontal length, that's what cosine is relative to, and the horizontal length is relative to the x-coordinate, which gives us our horizontal measure, which is important to remember. So let's try letter B. 5 times the cosine of 180 degrees. Here's 180 degrees. So it's going to be right over here. And of course, cosine, as we mentioned, is relative to the x-coordinate. So this is -1 over here on our unit circle. So then 5 times -1 winds up being -5. So if we go to our calculators, I could simply type in 5 times the cosine of 180 degrees, close off your parenthesis, and you have -5. So we're using our unit circle to confirm our calculator and using our calculator to confirm our unit circle. Let's try C. 17 times the sine of 330 degrees. 330 degrees, well, that's 30 degrees less than 360 degrees. So again, we have a 30, 60, 90 triangle. So we're looking for the opposite over the hypotenuse. Here's our opposite right here. That's a vertical length, and again, that's sine. That's relative to the y-coordinate. Of course, this is going down, so this is -1/2. using our pattern for our special right triangle 30, 60, 90 special right triangle. 17 times negative 1/2, that's negative 17 halves. Using our calculator, I could type in 17 times the sine of 330 degrees. Close off your parenthesis, and there we have it. Let's try letter D. The sine of 315 degrees. 315, that is 45 degrees less than 360, or 45 degrees more than 270. So the special right triangle that it's going to make is a 45, 45, 90. The sine, so we're going to be concerned with this length right here. And of course, that is negative. Using the pattern of a 45, 45, 90, that's negative root 2 over 2. 3.25 times the sine of 315 degrees. 3.25. That's equal to 3 1/4. And 3 1/4, that's 13/4. So we multiply that to negative root 2 over 2. And of course, I'm going to have negative 13 root 2. 13 times the square root of 2 is 13 root 2, and 4 times 2, that's 8. So 3.25 times the sine of 315 degrees, that's negative 13 root 2 over 8. Now to use our calculator to check, we have to be a little inventive to be able to do it. As if we did the sine of 315 degrees and then times that by 13/4. There we go. Now it looks like it. Let's try the final one. 4 times the cosine of 120 degrees. 120 degrees is right about here. Again, here's 90. That's 30. That's 60. So of course, the special right triangle, it's still a 30, 60, 90. We're looking for the cosine of this angle. That's the adjacent over the hypotenuse using the pattern of our special right triangle. This is going to be negative 1/2. Don't forget it's going back. So that's going to be negative 1/2. Times that to 4. 4 times negative 1/2. That's negative 2. So we'll give it a try. 4 times the cosine of 120. And it's negative 2. So we should always use the unit circle to help us with our calculator work, and vice versa. You should work them in tandem, work them together rather than separately.